Hi, welcome back to your new lesson. This is Lakshmikant Tiwari. In this lesson, I'm going to show you how you can do a multi-level image classifications using a movie's poster and convolutional neural network. So you will, at the end of this lesson, you will get a result something like this, in which you can pass a poster of a new movie which has just recently released, and then based on this movie's poster, alright, based on this poster, your convolutional neural network will suggest you a genre of this movie. So here you see it has suggested that this movie has a drama, action and the adventure based on this poster itself. Alright, so we have the few other posters as well for the testing. So what we will do actually, we will train our model based on the movie posters which is collected from 1980 to 2015. So these folders have a movie posters. You see these are the movie posters, and based on these movie posters, some movie posters are scary and some are adventure, some are actions. Alright, so based on these movie posters, we will be training our convolutional neural network which can learn to classify a single image in a multiple label. That's why it is known as a multi-label image classifications. You can also visit my channel KGP Talkie there, and you can watch other videos on TensorFlow 2.0 tutorials for beginners. And then you can go ahead at my GitHub repository, from where you can download directly the movie posters dataset. Although I'll be showing you how you can download this directly into your Google Colab notebook. So without wasting time, let's go ahead and start a step-by-step lesson. So I'll be doing a step-by-step coding for all these lines of code, and then I'll be describing also in meantime why I am writing these codes. Okay, so without wasting time, let's go ahead and start a brand new lesson. Alright, so in this lesson we are going to learn how we can do a movie genre classification based on a poster of the movies, and we will be using here a convolutional neural network. This will be a kind of a multi-level image classification problem. Earlier we have been doing a multi-class classification problem. Alright, so let's understand what are these problems. If I say a picture have if I say to you classify some picture in a single class, and let's say you have a multiple classes like you see here. All right, so cloud and then sun and then moon, and only you need to classify it in a single class. All right, like this is a cloud and this is sun and this is a moon. But what would happen if your image have these two classes together? Alright, like a sun and a cloud together? Then how would you classify this? Because it neither fall under a sun and it neither fall under a cloud and nor a moon. It is a kind of image which is having cloud and sun together. That's mean a single image is having a multiple classes together. So this kind of a problem known as a multi-label problem. That means a single image have a multiple classes, and multi-class means your overall data have a multiple classes, but one image is having just a single class. But in a multi-label, your image can have just a single class, your image also can have a multiple classes like this. See here, this image have just a single class which is moon, but here this image is having all these three classes together, like it has a moon, it has a cloud, and it also has a sun. So this is a problem of a multi-label image classification, and we will be doing this with a convolutional neural network on a mostly Hollywood movie posters. For example, let's say if we go and see this movie Joker, right? So this has here a poster, a Joker poster, and you see we will be using this poster to understand what type of this movie is actually. Alright, so those movies, and this movie falls under the category of crime, drama and the thriller. And the data set is available at this link. You can visit this link. This link will be here. I'm gonna give this link here. Alright. Movie poster link. you can go ahead and download it from here. And here, so you will get it from here. I already have downloaded this movie poster. So it has a lot of the kind of the posters, and along with that it has a multiple levels. Like this movie falls under the category of crime, drama and a thriller. And similarly, if we see this movie Iron Man, this falls under the category of action, adventure and sci-fi. Alright, so similarly the other movies also falls. For example, let's say if we take this movie Avengers, we will see this Avengers falls under the category of action, adventure and sci-fi. Alright, so the poster of all these movies will be actually the uploaded on my GitHub repository here, a movies poster dataset. There we have a train.csv, and this train.csv have ID for each of these movies, and it has a genre, the movies which falls under which category, and this ID is, that's the images which is given under this folder, which is images. So we have a total 7,867 images here, and you see this movie, let's say the poster for this image. Alright, so with this we can see here, say here that this is kind of a drama and the love. Alright, Heart and the Dust. Let's go ahead and search this on the IMDb and see which type of movie is this. Heart and Dust. Is it the Heart and Dust? Let me see, sorry. It's here. Heat and Dust, actually. This is Heat and Dust. Alright, so this is the movie, and it contains almost all the a single poster from all the movies which is released in between 1980 to 2050s, and this link, the data set mostly contains all the Hollywood movies, and this movie is having drama and the romance, right? So similarly we are going to find out what is the genre of a movie based on their poster. Since we are classifying it into multiple classes, that's why it becomes a multi-level image classification problem. For example, you can also see here, if your class have just two classes, your problem have just two classes, so it will be like a spam and not a spam. But if your problem have multiple classes, like it has animals, dog, cat, horse, fish, bird, etc., then it will be a multi-class classification problem. But suppose that you have a picture which has here a cat and the bird together, then it becomes here a multi-level classification. Alright, so I'm sure you might have got the idea behind the multi-level image classification. Alright, let's go ahead now install a TensorFlow GPU 2.0. Currently we are having a beta version of a TensorFlow 2.0. So you need to run this, but before you install a TensorFlow GPU, you need to also set a runtime. And here we want the runtime as a TPU. Okay, and save it, and after that you need to install this GPU on your Google Colab notebook. Alright, so it will take a little time to install its to complete its installation, but in meantime I can also show you my previous videos on my channel KGP Talkie. There you can go ahead and watch all these videos which I have made on a TensorFlow 2.0. And if you go in these playlists, you will get other videos as well, like a TensorFlow 2.0 tutorials for beginners and feature selections, machine learning with theory and examples in a Python. So these are the quite good the lessons on machine learning to get you started. Now let's come back here. It is almost installed, and in meantime let's go ahead and add few code cells so that we can work comfortably. Alright, so here we have it, installation is complete, and then we need to come here. Alright, so we are here. Let's go ahead and import TensorFlow as TF. sorry, this is not TensorFlow. This should be actually a TensorFlow. All right, so is it installed? It's installing, that's why it is not giving suggestions. Otherwise it might have given suggestions if I type just a tensor. All right, so TensorFlow GPU 2.0, that's the beta version, has been installed. Now let's go ahead and import sequential model, and we are going to import that from TensorFlow, sorry, a TensorFlow dot Keras, and then we need here import sequential. All right, all right, so we have here TensorFlow, sorry, we need to write here actually from TensorFlow.keras import sequential. So we have here sequential model and TensorFlow as a TF, and then we need also layers for this, and those layers we can get from TensorFlow.keras.layers, and then import here a flattening layer, and we also need here a dense layer. We also need a dropout, as well as we also need batch normalization. Apart from that, we are also going to work on convolutional 2D. We need conv 2D, and we also need max pool 2D. Sorry, we need 2D. All right, so apart from that, we have here layers which we are going to use in our lesson. And apart from that, we also need optimizers and pre-processing, some pre-processing libraries as well. So we need it from a TensorFlow.keras and then .optimizers, and then import ADAM. So we are going to use here ADAM optimizers, and apart from that, sorry, import ADAM, and then from TensorFlow.keras.preprocessing import image. All right, so these are the necessary libraries, and apart from that, let's go ahead check a current version of TensorFlow which we are actually using here, that we can get with tf.version. So it should say 2.0. Yeah, exactly, it's correct. Now let's go ahead and import some supporting libraries as well, like import numpy as np, and then import pandas as pd, and apart from that, import matplotlib.pyplot as plt. All right, and apart from that, we will be also needing some other libraries like the train test split and tqdm. So we can also import those libraries as well. So we will be importing those scalar dot actually model selection, and then import train test split. And apart from that, we also need from the tqdm import tqdm. All right, so these are the necessary libraries which we will be using throughout this lesson. And now let's go ahead and clone this repository, which is having a CSV file and the images. For that, we can copy it there, and then we can write it here, git clone, and then repository name. Okay, so it will take a little time. Let's wait for this. All right, so the GitHub repository has been imported in our local file here. You can come in files and refresh it. Now you see a movie poster dataset. This folder we have got it. It has a folder image in which total more than 7,000 images are here, and here it has a CSV file as well. So what we need to do here, first of all, we need to read these CSV files and which have the address for each of these images, okay, which are inside this folder. And then we can read the CSV file using pandas data frame. And let's go ahead and read that. In data is equal to pd dot read underscore CSV, and then we need to get the address for this train.csv. You can just copy this path, and then finally we can give this train.csv. Alright, so let's go ahead and see a shape of this data, which we can say just data.shape. It will take a little time to complete this. Now you see it has a total 7,254 rows, and each of these rows are having 27 columns. But if you see here, this movie poster images have total 7,867 movie posters, but this CSV file is having just 7,254 entries. That's mean there are around 600 posters we are not included this in this CSV file. Let's go ahead and visualize the CSV file and see first few lines of the CSV file by using a head command of pandas data frame data.head. And if you see in this, you see here it has a ID, and these ID is corresponding to image IDs. All right, image IDs means these are corresponding to the name of the images. All right, so ID is corresponding to name of the images, and then dot jpg, which is a image file name. And then genre is having whether this movie belongs in with what genre. Like this movie belongs to comedy and drama, but this movie belongs to a drama, romance, and the music. With this, now you can understand the concept of a multi-label image classification. There is just a single poster, but that poster is having a multiple genres. Since this is a multi-label image classification, in this we will be having a true value for a multiple labels in a single time. So that's why here we are having kind of this kind of the label, like let's say this image belongs to comedy and drama, and for that in the comedy column this will be 1, and in drama column it will be 1, and for other columns it will be the 0. And similarly for here you see for a drama it will be 1, okay, and for romance you see in a romance that will be 1. Romance is somewhere here, you see romance, and all other are 0. And another one is music, so music is somewhere, yeah, it is here. All right, so this is how we will be doing this multi-label image classification. All right, so let's go ahead and define the image size. And the image size which we are actually having here, if you open this image, and it's you see here there are different size of the images which we are having, but for processing we need a same dimensions for all the images or for all the files. So the dimensions should be the same. So what we are going to do, we are going to pre-process those images, and then we will reload that in some particular fixed size. So that I'm going to define with img width, which is actually the 350, and then I'll be defining it as img, and then height is equal to 350, and then I'm going to read this into x vector, which is just a empty list. And now let's go ahead and apply a for loop here. For I in TQDM we are using so that we can also show a progress bar while loading the images. And there we have TQDM and range, and then here we have a data shape, and then here we have a 0. All right, and then let's go ahead and get the path for all of these images. So what we are going to do, we are going to take the address of these images. All right, so let's go ahead and get the path for that images that we get inside a content, movies, poster, dataset, and then images. And then what we are going to do, we are going to add the ID. If you expand this, it will take a little time to show you. Then inside these images we have the posters. the name of the posters belongs to the ID. All right. So for that, just wait for a few seconds. Let it expand first. So all right. So now you see this ID name and plus JPG, and ID name we will be getting from here. So that we will be getting from data itself. So that we get from plus data, and then for first row it will be a 0. That belongs to I actually. First time it's 0, 1, 2, 3. That's mean it's I. And then for the next one, actually otherwise we can do I. Otherwise we can do also do with the ID. So let's go ahead and get first this series, and then for a 0, 1, 2, and 3 kind of this. And then next we will be getting here with the I. And then we need to also add the file format of these images, which is JPG. And we can do that with JPG. All right, so with this we get the path of the images, and now let's go ahead and load these images in img folder, img variable that we can do with image dot load image. And inside this we need to also pass here a path of image which we are going to load, and it will iterate to all these images inside this folder, image folder. And after that we also need to define here a target size for all these images, which we have image width and image height, which we can do with image width and then img height. All right, so with this, and apart from that, since this is colored image, then we will be also needing here a color scale as well, which is 3 dimension. Now apart from that, since the values in these images are from 0 to 255, but artificial neural network works well if values are somewhere in between 0 and 1. That's mean we need to first convert it into a NumPy array, and then we will be dividing its value by 255. So let's go ahead and do that, which we can do with image dot image to array, which is img to array, in which we are going to pass here image, and after that I'm going to divide by 255. So it has 255.0. That's mean it should be into a numerical value. All right, in a floating value. And then after that I'm going to call here x dot append, and then all these array for each of these images is going to be stored into this list. So that we can do like this, x dot append img. And apart from that, once it is done, then let's go ahead and convert this x into an array, which we can do with numpy np dot array, and then pass this x. Let's go ahead and run this. It will take a little time to load all these images. But one more thing you would notice here, this RAM size. A RAM size will change drastically, but by default it offers a 12 GB of RAM. That will be not sufficient to process this file. So what would happen the first time your the Google Colab notebook will crash, and after crashing, then Google will ask you to increase your RAM. So once it asks you increase your RAM, then you can just click on and it will increase your RAM to 25 GB. So that is almost just a double. All right, just wait for a few seconds. It will definitely crash. So it is completing a process, but if you see here, a 10.71 GB of RAM has been used out of 12 GB, and yes, your it has crashed. Now let's go ahead and click on this, get more RAM. It says that, do you want to switch it to high RAM runtime? Yes, I want to switch it. Then it will reload this, all this notebook, it will reload, and it will again connect it to a 25 GB of RAM. Now you see a RAM has been increased to a 25.51 GB, which is almost a double. But the one thing you might notice here, that our file has been gone here because we are having here a new runtime. So that means we have to again run all these things from beginning. So you can come here in a runtime and you can verify that you are still at a TPO. And now let's go ahead, rerun this, and you need to do it, right? So once your the notebook runtime resets, then you need to reinstall all these things. So it will take just a little time. Let's go ahead and install this. All right, so it has installed, almost installed. Just wait for a few more seconds to complete its installation. And you see here, currently we are using almost 1 GB of RAM, but still we are having more than 24 GB of RAM available for our purpose. All right. So it says that successfully installed our GPU 2.0. Now let's go ahead and import other necessary libraries, which we have already done. It won't take much time to do these things. All right. So here it will clone in just a few seconds, and then we will be running this data, and then after that we will be seeing this head. All right. It's done here. Now we are going to load all these images. But if you now see here, our RAM will go around 11 to 12 GB, since we are having here enough RAM, which is 25 GB, so it will not crash this time. All right, now you check here, almost 100% file processing has been done. And if you see here RAM size, which we are having currently a 20 GB or 18 GB. All right, so we have a total 25 GB, so we are in a safe side. But although we have reached that limit where our notebook might crash. All right, so yes, it has returned to 14 GB, so it has almost done a pre-processing here. Then after that, once it is done, then we will see here the save of X array, which we can do with X dot save. All right. All right, so X dot save, which is having here 7254 into 350, 350 and 3. So this is the image size actually. Let's go ahead and see any of the images, random images, which we can see with the plt dot imso, and then we can pass here some values. Let's go ahead and plot the first image, I mean the second image, x1. So you see we have this image. All right, and the pixel size is 350 into 350. Now what we are going to do, we are going to see a genre of this image, and the genre which we can see with, which is available in data, and inside the data we are going to see with the genre. All right, and that is the first location. So it has, this movie belongs to a drama, romance and music. All right, so this is how we will be doing. Let's go ahead and prepare our training and the testing data set actually. So we have loaded all these images in our X here, and now what we are going to do, so these will be actually our now the target. Earlier we have been working with just a single column target, but here we will be having a multiple column of a target. So target will be into a Y. And how would you get a Y? We have already got our X, which is a feature space, feature vector. We can get Y with the data, and then we need to drop here. There are few the labels which we need to drop, like ID, and then here we need to also drop a genre. All right, and then here we have here axis is equal to 1, and then we have Y is equal to Y dot 2 dot numpy. All right, so with this our Y has been converted into a numpy. Let's go ahead and see a shape of Y, which is 7254 rows and 25 columns. All right, so these are the 25 genres in which we will be classifying all these images. And to do that, we need to first call here our training and the testing data set, which we can, we need to divide our original data set X into training and the testing, which we can do with X train and then X test, then Y train, and then finally Y underscore test. And then here we have train test split, in which we will be passing here X, Y, and then random state. All right, that will be equal to 0, and then here we will be having here a test size, which will be 0.15, just a 15% for a validation. All right, so we have divided our training and the testing data set. Let's go ahead and start building our CNN model. All right, so from here we are going to build our CNN model, and that we can do by calling first sequential layer. So that's the model is equal to sequential, and then we need to add here our first two-dimensional convolutional neural network. That's the conv2D, and it asks about a filter. How many filters? I'm gonna give here a 16 filters, and then it asks about a kernel size. I'm going to give here a 3x3 kernel size, and apart from that it asks about activation function. So the ReLU is universal activation function nowadays, and in very first convolutional layer we also need to give input shape, and the input shape which we are currently having, that belongs to x underscore train, and for zeroth the arguments, and that will be a shape. All right, so if you see this here, that is a 350, 350 and 3. So this will be a shape of our input. All right, so after that we are going to add here batch normalization. So by model dot add, and then we are going to add here batch normalization, and once it is batch normalized, then we are going to add here a max pool. So we are going to add here a max pool 2D. A pool size will be here a 2x2, which is by default pool size, so we are not going to give. Otherwise you can also give some name, the pool size as well, for a better understanding. And then after that I'm going to add here a dropout. All right, so a dropout I'm going to add here 0.2, which is 20% of neurons will be dropped randomly. So this is the first layer of our convolutional neural network. A first layer has been completed. Now let's go ahead and copy this. We are also going to add 2 more layers or 3 more layers to complete this. So in second layer, if it is not if it is internal layer, then we don't need an input shape. We can just remove that, and we are going to change here 32 filters, and the max pool and the normalization will be same here, and the dropout we are going to set here 30%. So 30% neuron will be dropped here randomly to make our model a better generalized model. And in the third stage we are going to give here 64 neurons, and neurons, that's the unit actually. And now we are going to drop here a total 40%. All right, in fact what I'm going to do, I'm going to also make it 30% and 30%, and there is 40%. After that we are going to put here a final fourth layer. All right, in a fourth layer I'm going to give here 128 units, and in final layer I'm going to drop here a 50% of neuron. So this is a 4 layer of our convolutional neural network. Then after that we are going to convert here multidimensional data into a vector, which we can do with flatten. All right, so with that we can do with the flatten. Now it's the multidimensional data has been flattened out, that is converted into a vector. And now we are going to add here a fully connected layer, which is actually a dense layer. In the dense layer, the first we are going to give 128 unit, and then here we have activation function, which is actually a ReLU activation. And then we are going to add here a batch normalization. All right, and after that I'm also going to add here a dropout. So here I'll be using 50% of a dropout, that's the 0.5. So this is the first fully connected layer. Now let's go ahead and add a second fully connected layer, and in the second fully connected layer we will be having here a same number of units. And then let's go ahead and add a final output layer. All right, so in a final output layer what we are going to do, there is a trick actually, right? So here we will be adding a dense layer as usual in output layer. Since there are 25 categories in our Y, if you see Y is having 25 category, that's mean we are going to get we are going to predict any of one category or a multiple category. All right, so we will be needing here 25 units. And for activation function, do remember here we are not going to use here a softmax, but we are going to use here a sigmoid. Because why we are going to use a sigmoid? Since all these layers, actually, I mean all these columns, if you see here, those can be predicted either in 0 and the 1. And for that prediction, a sigmoid activation function is the best function. So that's why we are going to use here a sigmoid. So we are done with our model preparation. It says that we have something wrong here, which is actually at line number 3. Let me see. Yes, we need to also add one more bracket there, and then it says that at line number 8 we are having, I think, the same kind of problem. All right, and I think for all others we will be having same kind of problem. Okay, yes, so it's okay for here. So we are done with our model preparation. Now let's go ahead and print a model summary, which we can do with the model dot summary. Here we have a model summary, and in this model summary, if you see, we have a total more than 6 millions of parameters. So definitely the training for this neural network is definitely going to take a lot of the time. Let's go ahead now, compile this model. We can compile our model by calling model.compile, and it will be asking about the optimizer. So first optimizers, I'm going to set here ADAM optimizer, and apart from that I'm going to set here loss function. Since this is kind of a binary classification for each classes, there I'm going to set here a binary cross entropy. Alright, so here we have set binary cross entropy, and the metrics on which our model will be evaluated, that will be used as a accuracy. So alright, so here our model has been compiled. Now we have reached into a most interesting part of our model, that is a model training that we can do with the model dot fit, and then we have here x underscore train and then y underscore train, and apart from that we are going to train this for 5 number of epochs. And then for a validation data set, we are going to use here a validation data. In that validation data, I'm going to use x underscore test and then y underscore test. All right, so this will be used for validation data. Let's go ahead and run this. Yes, so the training has been started. It will take a little time to complete this training, so let's wait for that some time to complete its training. So at the very first epoch, after 64 iteration, it has reached around 50% of accuracy, which will hopefully increase to around 70 to 80 or 90%. So I'm hoping that we will get somewhere a 90 or 92% of accuracy for this multi-level image classifications on this movie poster. So let's go ahead and wait for some time to complete its training. Alright, so the training is done here, and we have achieved maximum validation accuracy 91.2%, and similarly we are getting here 91% of a training accuracy. So with this we can say that the validation accuracy is less than a training accuracy. That means our model is not overfitting, but it is some kind of underfitting, or it's okay. I mean, we have here our stable model, neither it is underfitting nor overfitting. Alright, so we have achieved here 91.2% accuracy. Let's go ahead and see a learning curve. So I have already written a code for a learning curve, and if you remember, and if you have watched my previous videos at my channel KGP Talkie, there I have a new playlist about TensorFlow 2.0 tutorials for a beginner. So it contains 12 lessons till now. You can go ahead and watch those. There I have covered in third and the fourth lessons how you can plot a learning curve in very detail. So I have a code here already. It takes 2 parameter, a history, that's mean this training history, and the how many number of epochs. After that, it plots training and validation accuracy with these 2 lines of code, and with these 2 lines of code it plots the loss of training and validation set. So let's go ahead and run this cell. After that we need to call here a plot learning. Alright, so we have here a plot learning curve in which we are going to pass here a history, and we have trained it for 5 epochs. With this we can see whether our model is underfitting or overfitting. So with this you can see here constantly training and validation accuracy is almost same, but if you see here validation loss is always less than training loss. So with this we can make sure that our model is not overfitting. So we have here a perfect model. Somehow it is very small or very, actually you can say a tiny underfitting, but it's okay and it can work. Now we have got the accuracy, we have trained it. Now the time to test some real image. So what I am going to do, if you see here, it contains the movie posters of in between 1980 to 2015. So I'm going to take some few new movies and the poster from new movies like Endgame. Alright, so like Endgame, Avengers Endgame, which was released in 2019. So this training set, which I have here at my the GitHub repository and which is also available here to download, it doesn't have a poster of Infinity Avengers Endgame. And similarly, I'm going to also the download the few other posters. In fact, I have already done Fast and the Furious. I have taken a posters of Fast and the Furious, and then I have a posters for a new movie, Sahu, and then here is another movie, Endgame. So I'm going to test these three images, which is actually not available in movie poster dataset. And if you see inside this dataset, we have so many movies, and these are the movies. All right. So now what we are going to do, we are going to just upload these three images on the file on this actually in file tab that we can upload here with this, and then you can upload it these three files: Fast, Sahu, and Endgame. And once our this Google Colab notebook restarted, so these file will be lost. So what I'll do, I'll upload these posters in my GitHub repository as well after the end of this lesson, and you can get the link in the video description. Now let's go ahead and do a real testing. Testing of model. So for a testing of model, if you remember how we loaded our images, we need to do the same things to load these images for a testing purpose. So we can copy this actually from here. All right, so we can copy that and then we can paste it here, since we need to do a same processing here. And there we can actually delete this one, we don't need. And here we need to give a path, since this is in the root directory. Let's go ahead and just give a direct name, endgame.jpg. all right, so here we have this image has been loaded and this image then converted. What I'm going to do here, I'm also going to show this image as well. And to do that, what I can do here, I can just write here plt.imshow and then img. All right, so once it is loaded, then it is being converted into array, and then array is being divided by 255. 255.0 will make sure that a new array should be into floating numbers. And then finally, I am going to delete this line. Now we have our img. Now we are going to reshape it so that it can fit into a model like we did here earlier. If you remember, we had reshaped it somewhere. Perhaps is it here? No, we had reshape somewhere. Let me show you. Do we have a reshape? We should have reshape somewhere. All right, it actually, I don't think it needed any kind of the reshape. So it was actually already in a shape, so it didn't need a reshape perhaps. So let's go ahead with the img, which we need to reshape it with the img dot reshape. Then we need to make it 1 cross img width, and then we also need to make it img height, and then 3. So this is 350 into 350 into 3. All right, since 3 is, it's a 3-channel color image, which is RGB. and with this we have loaded our image. So let's go ahead and see. So now you see here we have our image for end game, so we have loaded it. Now after this, what I am going to do, I am going to call I'm also going to get the classes. So how many classes we have actually in which we can classify any images, I mean the target classes. So those target classes are saved into columns vector, okay, data dot column, and from it is saved from second column onwards. Okay, I can show you that what I mean. So why it is saved after second column onwards, if you see these first two column actually ID and the genre is not actual target, the target is after a second. So that's why I have taken the column and then two and then contains all the other columns as well. So you see here these are the columns which is available. All right. Sorry. Now let's go ahead and make a prediction. So here we are going to first calculate the probability for each of these classes in yprob is equal to model dot predict. So this will return a probability for each of these the labels for IMG. That's mean this end game. All right. So then I'm going to get the top 3 prediction. All right. So with this I can get a top 3 predictions in which I'm going to get the maximum from the probability array. So that I can get from the arg sort. So let's go ahead and sort this, and what we are going to sort it. In fact, instead of that, let's go ahead and see what is the y probability. Perhaps after that then you can understand. And then I need to also bring it here, and then let's go ahead and see this. Now you see here the y probability. So there are in the classes. So if I print these classes as well, I can print these classes. So here you see these arguments are with related with the classes. You see the Avengers Endgame is adventure movie. Yes, it is adventure. So it has written there, you see the adventure. I mean it is getting a maximum probability. It is also action movie. That's when the probability for action is also pretty much high. And it is here you see this is also very high. So let's go ahead and see these the top 2 or the top 3 the probability. All right. So for top 3 probability, what we are going to do here, we are going to get these maximum 3 arguments, and that we can get here. Let's go ahead and in fact get the top 2. A top 2 is equal to in fact not a top 2, top 3 is equal to np dot arg sort. So it will sort it. All right, it is going to sort this array, and once it sort this array in argument wise, then what I'm going to do, I'm going to call here y probability. Since this is a 2-dimensional array, so I'm going to take the first dimension there, y probability 0. And if you see here y prob 0, then you see here we have this 1 dimension. All right. So after this y prob 0, then I'm going to get all these in the top 3 actually. So let's go ahead and print this top 3, what we get. All right. So do we get in top 3? Yes. So after this actually we also need to get those top 3 as well, so that we can get from the -4, since we have just sorted it, and now we are going to get from -4. Sorry, I mean the top 3. So those top 3 is here. All right. So these are the top 3. Otherwise I can pass here the parameters and sort it into ascending order. So what I'm going to do here, I'm going to take these 3. So these 3 I can get with -4 and then -1. Then it will return. All right. So it returns 7, 4 and 1. All right, so 7, 4 and 1. Now let's go ahead and print the classes for these three actually. And to print the classes for those three, what we can do, we can say for I in range of 3. All right, and then I can print the classes, and inside the classes I can say here a top 3, and in that top 3 predictions I need to pass here I. All right, so in this way it will make this top 3 predictions, and then after that I can just print it. Otherwise I can also print it what is the probability for each of these classes. So for that probability, what I can do, I can just call here y prob, and then I can pass here these top 3 and then I arguments. All right, so let's go ahead and see it. It says that some argument, so let's go ahead and remove this and then see what it returns. All right, so with this it says that this is a drama, a comedy and the adventure. So with this is somehow some kind of the misclassification, but otherwise you see you can definitely you can say that this is the adventures and drama definitely. And now let's go ahead and see for a Sahu. Okay, all right, so let's go ahead and see it for this one. So this says that this is drama, action and the adventure. Definitely this new movie which is just released just 3 or 4 days back while the recording of this video. So this is definitely, it has classified it perfectly. It is definitely a drama, adventure and action movie. And apart from that, let's go ahead and see Fast and the Furious, which I can give just fast.jpg. With this you can see here it's drama, comedy and the action. Definitely there is some kind of the comedy in that movie, but definitely it has actions and the drama. So with this, now I have shown you how you can make a multi-level image classifications on a movie poster using convolutional neural network. All right, let's go ahead and see the Sahu one more time. All right, so this is how it is working. So thank you so much for watching this video. Please do not forget to subscribe these channels, and if you want a new channel on any other topics, please comment below. I'll definitely try to make a video on that topic. Bye bye, have a nice day.